Welcome back, I guess, to another study session. So, yeah, I explained everything in the last video, so I'll just say that we're gonna get started right away. Okay, so I just read the exercise, and what it was saying was basically that we have this figure right here, and there is a rope attached to those two masses. And yeah, so the first part of the exercise is to graph out, or I rather should say to draw the forces that act upon this object. So I'm just gonna do that real quick. I hope this doesn't look too complicated, but I'm just gonna explain that real quick. But as you know the drill of those videos, you should already be a little bit familiar with that content, but I'm just gonna explain that real quick. So we have this mass here, and there is of course the gravitational force acting upon it, so I'm just gonna call it gravitational force 1, so Fg1. And at the same time, the force that pulls this mass down is also pulling this mass right here, mass 2, in this direction. So I just drew it here as Fg1, which is this force here, is acting also in this direction for this object. Now at the same time, you also have the Fg2, that is the gravitational force of this mass pulling it to the ground. And this force right here, you can split it in two parts, which are the normal force, which is horizontal, or no, that's not horizontal, I'm sorry, which is vertical to the surface, and this surface obviously has a ground, obviously has an angle. And yeah, then you also have this force right here, which pulls the object in this direction, which I'm just gonna call FH for now. So let's get started. For the first part of the exercise, that is part A, the exercise gives us the mass 1 being 4 kilograms. So I'm just gonna calculate the gravitational force of the first mass as the first step. I'm just gonna calculate that real quick. Okay, I've done the calculation, and what we have is 39.24 newtons. And I think I forgot to mention what the exercise is actually asking. So for the first part, it's asking us if this mass right here this object has a mass of 4 kilograms, in what direction then is this mass gonna move? And yeah, for this question we gotta keep in mind that while this mass has a force and is pulling this mass in this direction, this object also has its own force that's pulling it to the ground, and because of the angle of the surface is pulling it in this direction. So the next step is that I'm gonna do is I'm gonna calculate the gravitational force of the second mass. So that being Fg2. The second mass is 6 kilograms. I'm just gonna calculate that, and went up with a value of 58.86 newtons. So the next step now is calculating the normal force, that is the force that acts vertical to the surface of the object. So since the question is asking us in which direction this mass is gonna move, and we know this force right here, we have to find out this force right here that is pulling the object in this direction because of the angled surface. So let's do that. And the way you do that is with the sine of this angle, and I did a quick sketch over here so I can demonstrate you. And so basically, if this angle was 0, then the normal force and the gravitational force would not have an angle. They would be the same line, basically. That makes sense. I hope that makes sense to you. But since we're putting an angle on the surface, as the angle increases, I should say, I guess, then this angle here also increases. So we can say that this angle right here is alpha. And alpha is also on this side over here, and I'm going to show you why. Since alpha is right here, and those two, oh, I should draw it like this, I think. Yeah, that's better for visualization. So if alpha is right here, and if we just, I guess, multiply this triangle or this side by 2, then we end up with this rectangle. And yeah, so alpha is basically this angle right here too. So it's fair to say that the sine of alpha, which is the opposite side divided by the hypotenuse, is equal to FH, being the force that pulls the object in this direction, divided by the gravitational force. But again, you should really be familiar with trigonometry in order to do these exercises. So yeah, I'm just gonna multiply the gravitational force so we can isolate this force right here. And then I'm gonna put in the values. Oh, I shouldn't have done that, but I did. Anyway, that being 30 degrees times the gravitational force of mass 2. I'm just gonna calculate that real quick. And we end up with 29.43 newtons. That being this force right here that pulls the object to the ground. Or I'm sorry, that pulls the object in this direction, not to the ground. To the ground is the force that pulls the object to the ground is the gravitational force. So now in order to find in which direction this object is moving, we gotta find out which force is bigger from those two, from this one and this one. So I'm just gonna take the gravitational force of the first object, and from that I'm gonna subtract the force that we just calculated. I'm gonna calculate real quick, and this leaves us with 9.81 newtons. Those newtons acting in that direction, since if it were to be a negative value, then the force would act in the. Okay, now that was it, and in this part of the exercise specifically told that we should not encounter for friction or the rope having any mass or something like that. But for the second part of the exercise, we gotta account for friction, and yeah, that's what I'm gonna do right now. So the second part is asking us how much mass can this object right here have in order for this system to not be in motion, I guess. And they also give us the coefficient of friction of this object right here and the surface. That coefficient being 0.3. And since now we have friction in the game, then this changes this force right here, because if there is friction acting upon it, then the friction acts in the opposite direction, and I just drew it like this right here, and this force right here cancels to apart this force out. So we gotta calculate the new FH, FH being the force that again pulls the object in this direction. So I'm just gonna do that, starting by calculating the normal force of the object, which is, if I remember correctly, yeah, I'm just gonna write it a different way. Okay, so we're searching for Fn, and we should look at this picture right here. Okay, so if we look at this picture right here, then we see that alpha, being this angle, has the cosine of the normal force, the cosine being the side that touches the angle. So we have the normal force and the hypotenuse, which is the gravitational force. So I'm just gonna use that. So the normal force divided by the gravitational force, and then I'm just gonna multiply by the gravitational force. So we end up with the normal force on the left and the cosine of alpha multiplied by the gravitational force of the second object. Yeah. Okay. I'm just gonna put in the values. And I'm gonna calculate that. And that gives us 50.997 newtons. Okay, so the next step now would be to calculate the new FH, which I'm gonna do right now. And the way I'm gonna do that actually is by saying that the new FH is equal, so FHB for the B part of the exercise, that the new FH is equal to the old FH minus the friction. Again, that's, like I said before, I explained that before, it's this force right here minus the friction that is being created. And the way you're gonna calculate that again is through, we have to calculate the friction, but I'm just gonna do it in this step right here, and the way you do that is by multiplying the friction coefficient times the normal force, which we did here. And I should, yeah, FH was 29.3 newtons minus that value over here, and I'm gonna calculate that real quick off camera. Okay, so after doing the calculation, we end up with 14.14 newtons. That being the force that, or I should better say what's remaining out of this force here. So yeah, now we just gotta find for the part B. So in order for this system here not to move, this force right here of this mass should be as equal as this force right here, in order for them to cancel each other out and for the system not to move. And the way we're gonna do that is by, what step is that? Step number 7. Okay, so in order to calculate the mass of, or the first mass I guess, is you take the standard force equals mass times acceleration equation, and then you divide with the acceleration, and you end up with force divided by acceleration. You end up with mass is equal to force divided by acceleration. And then we're just gonna put in this value right here, the 14.14 newtons, because again this is how much this force here was, that being the force that pulls the object in this direction. So we need a gravitational force of this object right here to be the same as that in order for the system to not move. Then we're just gonna take the acceleration of the Earth, and I'm just gonna calculate that as always, and we end up with 1.44 kilograms. So yeah, that was it. I hope you could follow through, and I hope whatever you're doing as homework right now is not difficult, in a way that you can actually do it. And yeah, I'm just gonna end it here, and thank you for joining me on this study sesh.